Right, here we go. Wednesday's live stream on how to boost your maths to levels 6 and 7. And today we're going to be looking at algebra. So I'm just checking the mic's working. The mic seems to be working fine. So without further ado, I'm going to give you 30 seconds to try and convert this one. So you split the indices up and use the surds to change how you write this using a surd. I'll give you 30 seconds. Have a go at that. Right, here we go. So y to the power of 2/3 is essentially what you got. It can be written in two ways. You can write it either as y to the power of 1/3 to the power of 2, or you can write it as y squared to the power of 1/3, and that's the one we're going to use because 1/3, okay, means cube root. So we could write this as y cube rooted squared, or we could write it as y squared or cube rooted, and this is indicating that we're going to put a cube root in here and we're going to write y squared down there. Right, let's see if you can just change this one in exactly the same way, so you can get the right power for the surd here and then work out what else goes under here. 30 seconds to do this one. Sorry about that. Not had so much preparation to get the size of this. It's still probably a little bit small. Let's just zoom in again a little bit more again. There we go. So we've got x squared y to the 5/2. So effectively what we have is a little bit of a tricky question here, how we're going to do this. And we could have x squared y to the half and then to the 5, and that would give us x root y to the 5. And so we could have x to the 5 and then you've got root y to the 5. Now that doesn't really agree with what we're doing there, so let's try that. Try and do it the other way around, and let's just raise this all to the power of 5 first. So we have x squared y to the power of 5 and then to the power of a half. So x squared y to the power of 5, multiply the indices when you've got power of a power, so you get x to the 10 and y to the 5, and all of that to the power of a half, which is just square rooting. So that's just going to be a square root. We don't really need to write anything in here. You can write a 2 or you can write nothing. So we could write this as equal to square root, because it's what half is. We don't tend to put the 2 for the square root. X to the 10 y to the 5. So we could have x to the 10 y to the 5. Right, another 30 seconds. Try and simplify this one down as well. And this one, try and see if you can get the numbers outside the root. Can that be done? Okie doke, so let's have a look at this one. So we've got 27 xy to the power of 4/3. Well, what I'm going to do is I'm going to do 27. We're going to cube root the 27. So I'm going to do 27 to the power of 1/3, and then I've got xy to the 1/3. I'm losing my numbers for some reason. To the power of 4. Now, the reason why I've done that is 27 to the power of 1/3 is the cube root of 27, which is 3. I've still got xy to the 1/3, so I've still got the cube root of xy. So I could have xy cube rooted all to the power of 4, and then the 3 to the power of 4. And 3 to the power of 4 would give me 81 on the outside. Now, the only thing is I've got my cube root in the wrong place for this bit, but I could change the order around. I could actually have x to the 4, y to the 4, and put the cube root around the outside of that. So I would write it as 8 cube root x to the 4, y to the 4. It doesn't really matter with these questions because they're just about playing around with the algebra and understanding all these things are equal. And as long as you understand all these things are equal, then you will be fine come a real GCSE question. Right, next up we're going to simplify some algebraic fractions. And how do you simplify algebraic fractions? Well, what you must do is you must look to factorize top and bottom and then cancel down factors. You can only cancel down factors. So I'll give you, this one should not take very long. I'll give you 30 seconds to have a go at it, especially as I've been talking. Okie doke. So, right, let's factorise the top. We can get 12 out as the factor. So we can write 12, open brackets, x plus 2. And on the bottom, we've got 3 goes into both. So we can have 3, open brackets, 7x plus 1. So there's not a lot we can do to cancel this down. We can 3 goes into 12 4 times. So what we can do is we can cancel that down to leave 4. So the answer is 4x plus 2 over 7x plus 1. Wasn't really a lot to do with that one. Now, a common mistake I see is students thinking, well, there's an x, there's an x, I can cancel that down. X is, you can't write x times everything on the top and x times everything on the bottom. That's the only way you can cancel x's like that. And then they might proceed to cancel 3 into 24 and then some of the 12. It just doesn't work. Okay, you have to factorize and only cancel down factors. So let's have a go at this one here. Same amount of time. See if it can be cancelled down. Right, so let's factorize this one, just like we did last time. Common factor here is 7. 7 times 7z will give you 49z, and 7 times 3 will give me 21. 6 into this goes 3, and 6 into this goes 7, so we've got 7z. So what you'll notice is I've got 7z plus 3 and 7z plus 3, just written in a different order, on top and bottom. And I can cancel those down. So I'm just left with 7, 6. Okay, another 30 seconds to do this one. Okay, so let's start by factorising. So the top common factor is 2x plus 3. Bottom common factor again is 2. And this time I've got 3 minus x. And it's only the 2's I can cancel out because x plus 3 is different to 3 minus x. So the answer is x plus 3 over 3 minus x. Right. Here we go, another one to factorise and see where you can get to on this. Right, do the same again. So we have got a common factor on the top of 10. And that leaves you 6x squared plus 1. No other common factors here, and we can't factorise the 6x squared plus 1. And here we can take out 3. 3 into 18x squared gives me 6x squared, into 3 gives me another plus 1. And we see that it's that we can cancel down, because we've got a common factor of 6x squared plus 1 top and bottom, and that just leaves us 10/3. Right, let's do some more algebraic fractions. Now what we've got here is we've got 1 over x divided by x over 13. Let's just give you a few seconds to look at this one. Shouldn't take 30 seconds, I'll give you 15. You can either do it or you can't, this one I think. Okay, let's see if I can finish it in the last 10 seconds. So it's the same as 1 over x times by 13 over x. Okay, so what we get is, because what I've done is I've done that divided by this fraction. Although there's lots of explanation to do. You've got 1 over x divided by x over 13. You turn this upside down and multiply by it. So that leaves you 13 over x squared. 1 times 13 is 13. X times x is x squared. And we can't simplify it any more than that. Right, another one. Have a go at this. Okay, so again, we take this fraction minus 5 over x and we turn this one upside down and times by x over y. And what you can see is, because these are times, you have a common factor. You've got a common factor of x and a common factor of x on the top and the bottom. So therefore you can cancel them down. So we're just left with minus 5 times 1 is minus 5. 1 times y is just y. If you don't quite like cancelling down, you might multiply out. And then you might see that you get your common factor that way. Either way, the answer is minus 5 over y. Another one for you. We've got to do the same again. So take the first fraction, 1 over 5xy squared, times it by the second one turned upside down, so we've got 3x to the 6 over y squared. And we just got one thing we can cancel down. We've got an x here, x to the 1, and therefore divide x to the 6 by x to the 1, we get x to the 5. So we get 1 times 3x to the 5 is 3x to the 5. 1 times 3x to the 5 is 3x to the 5. 5y squared times y squared is y squared times y squared is y to the 4. And there's nothing else that's common to both top and bottom. Okay, so we're going to try and add these two fractions. Remember what you're going to do with fractions? You need to get a common denominator. I'm going to give you 60 seconds because it's going to take a little bit longer to do this. Get a common denominator, then add them. Right, so common denominator. We need to find something both of these would go into. Well, there's no common factors. There's nothing that goes into x squared that also goes into 7y cubed. So therefore we can just multiply them. So we're going to times top and bottom of this one by 7y cubed. So this is going to be equals to 5y times 7y cubed over x squared times 7y cubed. Times and top and bottom by the same thing. Now I'm going to times this one by x squared on top and bottom. So I've got 5x times x squared on the top, and I've got x squared times 7y cubed at the bottom. So I've now got a common denominator. I'm just going to rearrange it to make it neater. 7x squared y cubed. And here we've got 7 times 5 is 35. Y times y cubed is y to the 4. Plus x times x squared is x cubed, 5x cubed. So we've now managed to add those two fractions together. Possibly could take out a factor of 5. Doesn't really help. Leaves you 7y to the 4. There's nothing really we can cancel down. There's no common factor top and bottom. Okay, so again we can't cancel. So that's probably the best form for a simplified answer. Okay. Same again, common denominator, off you go. Right, so our common denominator here, again there's no common factor, so we're just going to multiply them together. And I'll just get 8y cubed times x squared, so over here 8y cubed times x squared, times the top and by x squared. So I've got 5x squared times x squared minus Now I'm going to times this by 8y cubed. So I've got 2y times 8y cubed over 8y cubed x squared. I can now write the same denominator. And I'm just going to multiply the x squared by x squared to get 5x to the 4 minus, and y times y cubed is y to the 4. 2 times 8 is 16. And again, no common factors. Well, you could factorise this, but you're going to end up with surds in it. It's a difference of 2 squares. You could have root 5x squared minus 4y squared times. It doesn't make it any simpler, so there's no point in trying to do that. So on to our last type of question. We're just going to factorise some quadratics today to work on our skills on this. This is a tricky one. I'll give you 2 minutes to have a go at it. And if you really know your factorising, you'd have worked it out already. I'm going to give you a bit longer, so no worries. Sorry, I didn't realise I didn't have the mic on. Sorry about that. A minute now, because I think if you know your factorisation, you should be able to do it in a minute. I'll leave the microphone on for this one. Right, so let's have a look at this one. Now initially I had a quick look. I was doing this just as you were doing it. I thought, oh, let's have a look at 4x and x, and then I looked at 5, and I got 5 times 4 is 20, and then I get what if I put 5 there and 1 there, I'm going to get 20x and 1x. That's no good. Moving the other way around, that's not going to work either. So therefore there's only one option left. There's 2x and 2x at the front, and then I'm thinking, right, I want to get, it doesn't really matter where the 5 goes. All I can have is 5 and 1. Okay, 5 times 2x is 10x, 1 times 2x is 2x, add them together I get 12x, but I want a minus here and a plus there. So if I make these both minus, I get 5 times minus 5 times 2x is minus 10x, and I get minus 1 times 2x is minus 2x, which gives me the minus 12x. Remember, minus 1 times 5 is plus 5, 2x times 2x is 4x squared. So I have exactly what I need. So this is my final answer. Another minute. Okay, so let's have a look at, oops, sorry, I've done a wrong thing, don't know how I got the highlighter there. Right, so I want to get 5. There's only one way to get 5, 1 and 5. Now actually, I've already done this question twice. I got 2x and I got 2x here as my possibilities, because if I do 2x times 5 I get 10x, 2x times 1 times 2x is another 2x. Now if I take them away I get the 8x, so I want them to be subtracting. Now I want a minus 5 here and a minus 8, so I want the big number to be minus. So if I put a minus with the 5, that'll give me minus 10x, and I times this by this. And I put a plus 1 with the 2x, I get a plus 2x, and they combine to give me minus 8x. 1 times minus 5 is minus 5. 2x times 2x is 4x squared. So I've got the right answer. Right, just a couple more and more interesting ones to do, and then we're done. So here we go. We're going to do this special factorization. Off you go. Right, this is a special type. If you can spot it, you'd have done this in about 2 seconds flat. Now what you should have needed to spot is it's difference of two squares problem. and you've got a squared minus b squared always factorizes to a minus b times a plus b. And if you think about it, a is equal to, well, 4x squared is the same as 2x all squared. Do 2x times 2x, you get 4x squared. So therefore a is equal to 2x. So we can put 2x everywhere that a would be in here. Then at the end we've got 25. Well, that's b squared, so b must be 5. So you can either do it that way. Sorry, I need to change one of those to a minus. You can either do it that way, and just remember a squared minus b squared is always a minus b, a plus b. Square root that, put them in here. Or you could just do it the old way, which is, okay, I'm going to do 2x times 2x to get 4x squared. I need two numbers of times to give me 25. And then when I combine these, it must give me no x's. So you know that actually this times this must match up with this times this and have a different sign in the middle, okay, for it to work. Anyway, it's a standard one. When you see those ones, you should be able to do that. And last, this is a really quite an easy one. Let's give you 30 seconds and see if you can knock this off. Right, so remember I said about looking for common factors first. Look for common factor. There's x and 4 that goes into both. So 40 divided by 4 is 10. X squared divided by x is x. Plus 16 divided by 4 is 4. X divided by x is nothing. And what you can see is I've still got another factor. I haven't finished off. Actually, 8 goes into both of these. Got a 2 here and a 2 here. So take another 2 out. So I've got 2 times 4x. Take off, divide that by 2, I get 5x. Divide that by 2, I get plus 2, and there's no more factors. So 2 times 4 is equal to 8x. So it doesn't matter if you don't spot all the factors in one go. You can still get to the right answer. Now, these are all off the level to 6 to 7 algebra boosts on My Maths. I'll put a link in at the beginning of this sheet, this top sheet here. Okay, I'll put a link to the My Maths there when just after I finished streaming, and you can go and practice some more of these types of questions if you didn't quite get them the first time when doing this video. Thank you very much. 8 to 9 is tomorrow, and then we'll do another 6 to 7 next Wednesday at the same